Well, hello everyone. My name's Steve Maxwell, and in a few minutes I'm going to be starting a live Q&A session. I'm sitting right here in my workshop right now. I can't really tell if the sound is coming through okay and if the video looks all right. So just before we get to the 4 o'clock start time, could anyone out there drop me a line? Just type something in the interface. Let me know how I sound. Let me know if the picture looks good, and if all is well, we'll get going in a minute or two. Good. Well, thank you, Kat and Mark, for responding. Now I know things work. It's always a little touch and go doing these leading edge technological things. But my name is Steve Maxwell. I'm a cabinet maker, carpenter, and stonemason. And since 1988, I've been helping people to make the most of their homes, and workshops and gardens and rural living. Essentially, I write magazine articles, newspaper articles, and I do online stuff about my life. I'm constantly working on projects with my own hands. I live in a rural area on Manitoulin Island in Canada, and I interact with a lot of people, a lot of homeowners by email. And they ask me questions and I give them some answers. And that's what this 1 hour session is about here today. I'll be here for at least an hour, and you can type in questions for me to answer. I can see them coming in on my screen. I can't hear them, and nobody can see you, of course, but I'll read what the questions are coming in and do my best to answer them. Also, if there's ever any issues, if I don't answer the question properly, or if you want more information, then by all means, just contact me directly by email, like everyone else does. My address is steve@stevemaxwell.ca. My main website is baileylineroad.com, and you can get all kinds of articles and videos there for free. You can also sign up for my Saturday morning newsletter, which almost 30,000 people get right now every week, and they tell me they like it, so maybe you will too. Anyway, okay, I'm ready for your questions. The topic can have anything to do with home improvements, woodworking, construction, power tools, anything to do with your home. I have to tell you, though, that I'm kind of thinking a lot lately about finishing basements. And the reason I'm thinking about that is because I'm just finishing a course on this. It's actually one of the largest things I've produced. This will be an online course. It'll be hosted on the DIYuniversity.com. I'm one of the expert instructors there. And I also, with all of my courses on that platform, I provide one-on-one assistance, because every situation is unique, and I'm there to act as a coach. So I don't see any home improvement questions coming in yet. So I'll tell you about an email I got just before this session. It's from a man named Chris, and he's planning to build a new house. He wants it to be as efficient as possible, and he's wondering what he can do to insulate the outside of the basement walls. He wants to insulate inside, of course, and he wants to insulate outside as well. He's been advised to cover the outside with foam. There's also some rigid rock wool kind of insulating boards that can be put on the outside. But he's a little concerned. He's wondering about how something like this might stand up if it's on the outside of the foundation wall, extending right down into the ground. I mean, that's what has been suggested to him. Will it stand up to mechanical damage and backfilling and moisture? And my answer to you, Chris, is probably not. I often see attempts to insulate the outside of basement walls, foam, mineral wool, sheets. There are different options, but in every case, I've never seen them age well. I've never seen these situations look very good after 5 or 10 or 20 years, and that's because all of these insulation options are fairly soft, so they're susceptible to mechanical damage. And they can also absorb a lot of water too. So my short answer, knowing not a whole lot about your project, would be to keep the insulation on the inside. Durability is important. What's the point in having water saturated insulation on the outside of your building? Or what's the point in having some sort of parging over an insulating sheet if it just gets dented at ground level and damaged? So that's my advice to you. I never put insulation on the outside of foundation walls because I've never found a durable way to do it. So I hope that helps, Chris. Anyway, let me take a look here. Okay, so Mark is asking me, what's the best way to humidify and dehumidify a home? Well, I live in a part of the world where we get some pretty serious winter. It will regularly get down to minus 25 degrees Celsius. That's a little, maybe that would be about 4 degrees Fahrenheit or so. So where I live, the problem is often the houses getting too dry in winter, or at least older houses with a lot of natural air leakage. Now, at the same time, if you have a tight and modern house, then the danger in wintertime can be too much humidity. And that's shown by condensation occurring on the inside of windows during cold weather. And so depending on your situation, you're going to want to go about this in different ways. If you have an old house that tends to be too dry, you never get any condensation on the windows, and your nose is dry and bleeding, and relative humidity is down below, say, 30% inside, then the best option for you is to tighten up your house. Because the reason it's dry is because there's all kinds of outside air leaking in. It's cold outside, but when that air comes in and warms up, its ability to hold moisture increases. So when the temperature of air increases, the relative humidity will go down, all else being equal. Without losing or gaining any moisture in the air, that relative humidity is going down because relative humidity is proportional to the temperature of the air. That's why they call it relative. So if you tighten your house to reasonably modern standards, you're no longer going to have too dry of a home. You're probably going to have a home that's too moist, as evidenced by this condensation on the windows. So what I advise people is to tighten their house if it's too dry, but to ventilate the house more if it's too wet, meaning that the windows are wet on the inside. And the best tool for that is something called a heat recovery ventilator that exchanges inside and outside air, so you get fresh air, and it also reduces humidity. But it saves most of the heat that's in your home. Maybe 80% or so gets saved. So you save the heat before the air goes out, but you get fresh air. And depending on how much you use the HRV, running it more or less often, faster or slower, you can regulate the humidity that way. So I hope that helps, Mark. Let me know. Okay, we got a lot of questions coming in. I'm gonna have to stay here for more than an hour, I think. Okay, let's see. Now, Chris, whom I spoke about before, he's planning a new home, and he's wondering about insulation on the outside. He's asking about ICFs. Those letters stand for insulated concrete forms, and that's where you have foam on the inside, foam on the outside, and they're connected, and they form a form for concrete, and the concrete goes inside, and the foam is intended to stay on. It can be used for above ground applications and below ground applications. I've used it for below ground applications, but I don't really put a lot of faith in that foam on the outside staying in good condition. So, it can serve some purpose, but that foam is also going to get saturated with water in time and lose its insulation value quite a lot, in my experience, around ground level. So the ICF option isn't really going to help you out too much. So Anyway, let's see. Tom, what do I think about engineered wood flooring over concrete on an old home? And do you know about products like Delta FL? So, Tom, are you talking about a basement situation here? I think so. Let me know, but I think that's what you're talking about based on your note. I like engineered wood. Imagine maybe 1/8 of an inch thick or 3/16 of an inch thick layer of premium hardwood bonded to a plywood, usually plywood, sublayer that has very often click edges. So imagine a laminate floor with made of plywood, not MDF, but with real hardwood on top. That's engineered flooring. And the advantages are lower cost than an equivalent grade of solid hardwood and greater stability. So I like engineered hardwood. And if I had to put anything like real wood in a basement, it would be engineered wood, but never, ever, ever directly on the concrete floor. That's one of the things I mention in my basement course that's coming up right now. It'll actually be going live on January the 24th. And one of the biggest mistakes with finishing basements is putting a finished flooring directly on the concrete. There's all kinds of problems with that. It all comes down to moisture and temperature. So no problem with engineered flooring upstairs, and engineered flooring can be used downstairs as long as it's on top of an impervious subfloor. That's really essential, especially for something like engineered flooring. Okay, Tom, I hope that helps. Let's see. Scott is asking me what type of internet connection I have. Rural areas like where I live often have poor connections. I have to use a cellular-based connection to get any kind of decent internet. It's outrageously expensive, but it's the only way I can function like this now. I'd never be doing anything like this if it wasn't for that cellular internet. My bill every month for that, including my one cell phone, is always more than $500 a month. So this is a serious investment here, but it's the only option I have right now anyway. So let's see. Okay, Tom is asking me, any thoughts on the best way to prevent heat loss through an open wood-burning fireplace? And if building a new one, are there any recent innovations that could be incorporated? Well, you know, the thing about fireplaces is that they look nice, but they don't actually deliver a lot of heat to the house. They don't deliver a lot of heat when they're burning. Some actually consume more heat than they deliver if they have an especially rapid draft that extends up, and it can actually suck warm air out of your house. So you might be losing even if it's burning. And if it's just sitting there, there is a constant movement of air going up that chimney, even when the fire's not burning. And that's all heated air that's leaving your home, and it has to be replaced with air outside your home that has to be treated in some way, heated or cooled in the summer. So having a fireplace that closes properly and reliably between uses is very important. A properly built fireplace will have a flue damper. So a metal thing inside, usually with a little lever, and you can move it and you can close that. And that's a great idea. If your fireplace doesn't have that, then short of just plugging up the chimney with some fiberglass insulation or something like that, not very convenient. Short of that, then you'll have to have something installed. But it's definitely worth looking at because fireplaces can consume a lot of heat. They'll cause a lot of heat loss in your home just sitting there. So I would definitely look at that. I don't know of anything more fancy or handier than the old flue damper, or just plain blocking it up if you're not going to be using it anymore. So let's see. Okay, so Scott tells me that he has moisture between his double pane windows, and is this fixable? Well, first of all, your problem is fairly common. Modern windows nowadays don't have one piece of glass, they have at least two and sometimes three, and that space between them is usually filled with a gas that's a pretty good insulator, better than air anyway. Argon gas is one of the most common types, but the seal between the panes can fail. And when that seal fails, you not only lose the gas, but you can also gain some moisture in between. It's not necessarily going to show up all the time, but under proper temperature conditions, you can get some fogging going on. And if the leak is bad enough, you'll actually get liquid water forming in the bottom. It looks sort of like a little, very thin aquarium almost sometimes, and things will even start to grow in there under extreme conditions. I've seen that. So is there anything that can be done? Well, there are two things that can be done. First of all, any window unit can have its glass replaced, and any building supply outlet can order custom-made thermopane glass units to fit your window. So that's possible. However, an easier option, if they exist in your area, is to get the help of companies that specialize in fixing this sort of thing. So they have methods for going in and for reestablishing the seal, and for, in some cases, replacing the glass, or certainly drying it out so that you don't have this sort of problem. So you've got two options, and I think that that either of them will work quite well. I would first start looking around and see if there's someone in your area who offers the service. That would be the first thing to do. It's the easiest fix. But then there is the glass replacement option as well too. So let's see here. Lots of things coming in. So Michael, let's see. Michael is wondering about a product called Duoblast. That's a product that uses oxygen to remove stains. That came out in the summer here in Canada, and then in the fall in the US. It's a pretty amazing product. I tried it out. I did some video reviews about it. It's a two-part product. You have a regular plastic jug, but the jug is divided in the middle, and there's one chemical on one side and another chemical on the other. And then you open up the lid and pour it out in a certain way, and both of them mix, and it's ready to use. It's completely non-toxic, doesn't have much of a smell, smells a little bit like vinegar. It's quite pleasant to use, and it can, well, in extreme cases, it can turn a very gray, black, mold-stained piece of wood, and it can completely restore the natural color. It's actually shocking how well it works. And for some nice reason, just by coincidence, it doesn't remove any wood grain pattern. So it's not like bleach, in that it chlorine bleach, in that it bleaches out the all of the color in the wood grain. You're still going to get wood grain color if that's what you're working on, but it works really well. Michael seems to be having some trouble finding it in Canada. Email me, Michael. I can't see your whole message here, but it looks like you might have tried to email me and maybe I missed that, but it's steve@stevemaxwell.ca. I have the product numbers for all the different stores, so drop me a line and I'll send that to you. I think you'll find it works very well. Let me know here in these comments whether what your situation is, where you have the mold, and how you want to remove the staining, but it certainly does work really well. Okay. Now, as I said, one of the common questions I get, families of questions, I guess you could say, would have to do with finishing basements properly. And the reason I created this course was because I usually end up hearing from people who are finishing basements after the damage has been done, so to speak. Many basements are being finished today using methods that have an excellent chance of causing mold and mildew and poor indoor air quality. So the only way to fix this is to do it properly from the beginning, and that involves the use of a proper subfloor. I never recommend putting carpet and underlay directly on concrete. That's a recipe for trouble. Another common recipe for trouble is the use of stud frame walls on the perimeter of the basement with fiber-based insulation. This is especially bad if you use a wood frame wall on the perimeter, but it's still a problem if you use a metal stud frame wall with fiber-based insulation on that outside perimeter wall. And that's because of the moisture issue. That's really what separates a basement situation from an above ground situation, is this strange, unique need to manage moisture. Because even a very dry basement, a seemingly dry basement, can often have water vapor coming through. And that you can't see that. You can detect it ahead of time, and you should detect it ahead of time. But if you don't, and you finish in a way that is vulnerable to moisture, then you're going to have mold and mildew and musty smells. And that's why so many basements smell that way. It's because they were constructed improperly from the beginning in a way that is vulnerable to moisture. So the floor is one area, and the walls are another. And there is one particular spot that is that's very vulnerable, and that's what's called the rim joist area. So where the basement walls meet the floor of the level of your house above, so whether the ceiling joists in your basement or the floor joists for the level above, where they meet the outside wall, there's often very little material there. It's 1.5 inches of wood and then whatever siding you've got on the outside. And that's not a whole lot, which means that in wintertime, that area can get quite cold. And that's to be expected, but the problem is the way people usually insulate that, by putting in some fiber-based insulation and trying to cover it with a vapor barrier, which you can never seal properly around all those joists hitting the outside wall. So inevitably you have indoor air leaking into that space, and as it makes its way through the insulation, it cools down, gets to the dew point, and then droplets of liquid water just kind of appear inside the insulation. And of course, that's going to lead to moisture and building up and mildew and rot and things. So the best solution is some sort of a spray foam, at least 3 inches thick. Closed cell spray foam will act as its own vapor barrier in a situation like that. There's also less expensive ways of going about it, cutting pieces of foam and fitting them in. This is one of dozens and dozens of little strategies that I mentioned in the basement course. And as I said, I'd like to get the word out on this sooner rather than later, because none of these things can work properly after the fact when you're all done. So you've got to do it ahead of time. So let's see here. Oh, this is interesting. Lloyd says he's building a completely off-grid cabin near Lake of the Woods. That's in Ontario, the same province I live in. And I need advice on how to approach solar energy and lake water purification. Well, that's a great question. Off-grid energy systems are one of my specialties. It's another course that I have on the DIY University, so DIYuniversity.com. And I guess the solar energy side of your question, Lloyd, is different than the water purification. So in a nutshell, what you need to do is to start by deciding how much power you need. And that how much power question really has two parts, because there's the peak power demand, and that would be expressed in watts. So how much power you want to be able to use at one given time, at any given instant. A typical small solar system might be 2,000, 3,000, 4,000 watts at any one given time. Just to put that in perspective, a kettle, a plug-in kettle, might use 12 or 1,500 watts. Toaster oven, a lot of power as well. So there's the wattage, the peak power that you want to need. And then there's the quantity of energy that you want to have stored for use when your solar system isn't working, maybe at night or in cloudy days or things like that. So that quantity is expressed in kilowatt hours. So as opposed to watts or kilowatts for the peak power, kilowatt hours would refer to a quantity of energy. And so that relates to the size of the bank of batteries you want to have. That's kind of like your gas tank, so to speak. And the wattage, the peak power capabilities, that's more like the horsepower of your engine, to use an automotive analogy. So you need to figure out that. What's the peak power and how much power do I want to have in reserve? And then you build on top, you build around those numbers. So for instance, how much power you want to consume in a day eventually comes back to how much power you're producing, in your case from solar cells. And do you want to convert some of that from DC power, which is what solar panels produce and it's what batteries store? Do you want to convert that to AC power, alternating current, which is what plug-in items use? And the item that does that conversion is called an inverter, and inverters can only convert power up to a certain level, up to a certain wattage level. So with your basic numbers, peak power, how much energy I want to have stored, that will inform you about what size of battery bank, what size of inverter, and a whole lot of other things spin off from that. But I would mention one thing before I get to your water question, and that is solar and wind go together very, very well. So if you want a system that is as unlikely as possible to need some sort of a generator backup, I would strongly recommend going with a solar and wind combination. Solar is great because we don't always have wind, but up where you are in Lake of the Woods, there's probably a fair amount of wind, and it's not unusual for things to be windy at night. So when you're sleeping and you're not using much power and the sun is down, then your windmill can be charging that battery bank for you too. But anyway, I go into all this in my DIY University course, and you can go to DIYuniversity.com to see when the different course sessions are being launched. These courses include videos, photos, plans, schematic drawings, but also one-on-one access to me. And we'll go through your situation in detail, and I can make specific recommendations about how to do things. Now, as far as water goes, I think, well, there are different options. First of all, you're probably going to want some sort of a pump system, and that'll tie into your solar and wind energy plans. You're going to want to have some sort of a coarse filter, something that just keeps the little bugs and the zebra mussels out of the system. And then if you have a power system, you might consider going with a UV, an ultraviolet purification system. They don't require a whole lot of power, but they're quite effective, and they're not complicated to install. So that might be something that you'd consider. You're also going to have to think about pumps and tanks and all of the fittings that's going to make things work as well. But anyway, I hope that helps. Let me know. I've got my eye here in the comments, and you can email me too as well if you like. So Michael B, he's asking for my thoughts on magnesium oxide wallboard. Well, Magnesium oxide wallboard is a completely inorganic replacement for drywall. The drywall is pretty inorganic in that the gypsum core does not offer a food source for mold and mildew and things, but the paper on the outside does. The paper on the outside of drywall is organic, and it can support the growth of undesirable things. So that's why they invented magnesium oxide board, because it's completely inorganic. And some people use that in basements. I think it's a fine idea. It's more expensive and it's harder to find. And even as a person who recommends going to great lengths to eliminate mold growth in a finished basement, I wouldn't consider magnesium oxide board to be essential, because any properly finished basement is going to have a whole bunch of other things in place already to protect against moisture. I mean, first of all, you have to start with a bone dry basement. Second of all, you do water vapor testing. It's pretty easy. You just put tape some clear plastic to the walls and the floor of your basement, and you watch it for a period of weeks and see if any sort of moisture is building up. If it is, then there are waterproofing treatments you can apply. Your walls, your finished walls in your basement should not be part of a frame that's insulated with fiber-based insulation against a wall. It should be part of a foam-based insulation. Ideally, some sort of a freestanding panel on the inside. You do all these things, and you should never have any damaging levels of moisture coming in contact with your drywall anyway. Magnesium oxide board is not a bad idea. I like it. It's more expensive and more troublesome to find. And if you haven't done the background things, if you haven't done the proper moisture sensitive details in your basement, magnesium oxide board isn't going to save you either. I mean, it's just the last layer in a bunch of different things that you can do. So my short answer is not essential, but a pretty good idea, I think. Anyway, let's see. Okay. Tom's got a cottage question here. He's got a cottage in Nova Scotia, and he's wondering whether it would be better to have no heat left on in a winterized cottage, or would I recommend keeping heat on, and if so, at what level? Well, there's only one reason that you might want to keep heat on in a cottage, because it's expensive. I mean, Tom's place here has electric baseboard heating, and electric heating is always the most expensive option, in the final analysis over the long run. And it always will be the most expensive, because generating electricity involves a huge amount of waste. I mean, you've got an electrical generating plant, hundreds of miles away, maybe even thousands of miles away from your home, and it has inefficiencies. And then in the transmission of electricity, there's quite a bit of loss that occurs. So all things considered, it's going to be expensive. So to keep your heat on, even at, say, 10 degrees Celsius, which would be about the minimum you'd want to keep it at if you're going to heat it at all, that's still going to cost you hundreds of dollars over the course of the winter. And the only reason you might want to do that is to protect your walls. And even then, not in every situation. I know plenty of cottages with drywall, and they don't heat the cottages in the winter, and it's fine. Sometimes getting very cold can cause cracks to form in the wall that wouldn't normally form, but not always. And I would say not even frequently, but sometimes it does. So my advice to you would be to winterize the cottage, and draining all the water, putting some plumbing antifreeze in the traps, just doing all the regular stuff you do, taking all the canned goods out of the cupboards, and then leave it unheated. I live in cottage country too, and I get to see lots of cottages, and I haven't seen a very significant need to heat them over the winter, and it is an expensive proposition. I should mention something to you as well, Tom, about something I discovered this past summer. It's a device invented by a plumber here in Ontario, and it's called the Closer. Their website, I think, is Closer, CLOZER.ca. And what it is it's a reservoir and pump system that makes it very easy to pump plumbing antifreeze through the whole system. This makes it easier to properly drain the system, so there's no issues in the spring with burst pipes. And it's fast and easy and foolproof, really, because even when you drain the pipes in a cottage, condensation can develop inside the pipes as fall is moving into winter. And that condensation, if it builds up enough, can trickle down and pool in certain areas and actually fill parts of the pipe that used to be empty. So by injecting plumbing antifreeze through the whole system, you can sidestep that problem. And it's also pretty much the only way I know of to winterize things like a fridge with a water dispenser or a dishwasher or a washing machine. I mean, you can do things to kind of try to get the water out, but I've never seen anything that was completely reliable. So anyway, I hope that helps. Let's see what else we've got here. Okay, so Chris is asking me if there's any water and moisture barrier paint or spray that can be a barrier on rim joists, etc. Well, you know, I'll take the rim joist situation first. By barrier, I'm thinking that you probably mean something that would stop wintertime condensation on the rim joist area, or something that would function as a vapor barrier. And there are paints that are pretty good at that, but the problem is that any sort of a vapor barrier needs to be functioning on the warm side of the insulation that you'd put in the rim joist area. So I don't know any other way of insulating a rim joist without using some kind of foam. I mean, spray foam is fast and effective, but you've got to call in an applicator. And if that's all you have to do, he might have to charge you quite a bit just for coming out. Another option, and I explained this in my course, but where the floor joists meet the outside wall, you have a floor joist here and a floor joist here, and then there's a piece of wood that forms the outside of the wall frame. If you take some 2-inch thick extruded polystyrene foam, so that's not the white beady stuff, that's the other stuff that's smooth, it's often blue or pink, and using a handsaw, you cut a piece of foam so it fits between the joists and against the rim joist on the outside. But you size this thing so that there's at least a 1/2-inch gap all the way around the outside of this foam. So what you do is you put the foam in the space. A little bit of hot melt glue works really well because you need to hold the foam against the rim joist temporarily with the space all around the perimeter. And then you can take a can of spray foam and you can stick the nozzle in there and inject it. Inject foam all the way around the perimeter, and that will swell up, and that's going to seal, and that's going to do a very important thing. Working with the rigid foam that you put in, that's going to function as a vapor barrier situation. So the warm, moist air from inside your basement won't be able to get to the cold side of the foam. That's why we insulate around the perimeter, and it does a great job. I would do that twice for every joist cavity, so 2 thicknesses of 2-inch foam. It's kind of hard to find foam thicker than 2 inches, so that's why I'm suggesting you do it in 2 goes with the spray foam around the outside to seal it. And that's going to work really well. If you're nervous about using spray foam or you don't want to get into the expense, that's a great way to do it. And it's something that any handy person can do too as well. So I hope that helps. Let's see. Okay, we've got someone from Minnesota, and they're in the process of starting backyard chicken flock. So she tells me, Kat tells me, that she's reached out to local breeders and she's looked at coop designs, and she knows that coop ventilation is key. So she's looking for some tips for good ventilation and insulation. Well, as I mentioned before, I live in the country. We've kept chickens here for going on 20 years, and we've experimented with different coop designs. As it turns out, I'm working on another course about backyard chickens too. Just about finished that one. That will launch in February. But what I like is a mobile coop, so a coop that you can move. And in the design that I've come up with and that we've been using here for a number of years, it's the best design we've ever come up with. It has a hinged lid. So in the wintertime, we want the lid closed. The lid is the roof, I guess, and it's covered in clear roofing panels. So with that lid closed and 3 or 4 or 5 hens in the house on a sunny day, it can get very warm in there. Not too hot, but certainly if it's substantially below freezing outside the house, it will get above freezing during the day in there. And the hens really like that. They also like the light too. Hens actually benefit even more from light than warmth. So with this design that we use here, the clear roof lets warmth in. But in the summertime, it also gets pretty hot here too. We can hinge that lid open more or less as needed. And with the lid open, there's never any unusual heat buildup there, even though the ceiling, the roof is clear. And it works quite well. It's a very, I call it like a multi-grade chicken house. It works in the cold, it works in the hot, everything's fine. If where you live is really hot, and Minnesota wouldn't be one of those places, but further south, you can cover the whole roof when it's hinged open a little bit with some shade cloth to kind of shade it, or even move it into the shade. Because another thing I really like about chicken houses is when you can move them around. With ours, we park them in a certain spot and use some electrified poultry netting to create a kind of a free range yard that we can move if necessary. That's a lot better than a regular fixed on the ground chicken house, because the chickens will always stay there. You can't move the house around, so pests and disease and things can build up in the ground. The ground's going to get completely beaten down. There won't be any grass there anymore, and you won't be able to take advantage of all the manure that the chickens are dropping, because you can't grow anything on that spot because the chickens are always there. So that's the way we handle it, and it works pretty well. I hope that helps. Okay. Let's see here. Okay, so Elizabeth, she is wondering what advice I can give about replastering a non-commercial pool at a cheap cost. Well, to be honest, I don't have a whole lot of experience with pools. I mean, I've swam in them. I haven't had to refurbish them. But why don't you can maybe tell me in the comments here, you're talking about replastering. Is the inside starting to deteriorate? Maybe flaking off, falling off and things? Because if it is, then I think you need to talk to a pool specialist. The challenges of a pool environment are very steep. I mean, one of the jobs I do here, way out in the country, to make ends meet, is that I edit Pro Painter magazine. So this is a magazine in Canada and the US for commercial painters. And I happen to know from different stories that we've run over the years that meeting the challenges of coating the inside of a pool are pretty steep. There are different kinds of epoxy-based coatings, and you can't just use regular paint, and I'm sure you just can't use regular plaster if you have to fix that up, if there's deterioration going on. So I don't know of an easy way to do this, but one of the dangers with something like this is that you might go to a whole lot of work and just have it turn into a whole lot of disappointment. Because I'm all for doing things yourself. I do a lot of things myself, far more than most people. But I do know that if you go into particular situations without enough knowledge, then all of your effort and your materials can be for naught. So I don't want that to happen to you. So you need the advice of a pool expert, and I'm not a pool expert. So if I had your situation, that's what I would be doing. I would be doing some research online and talking to people and seeing what they recommend. So I hope that helps. Let me know some more details if I've missed a few things. You can send them on. I'll look out for that. Okay, so Mike Montrose from New York. He's just saying hello. I think maybe he gets my email newsletter. Okay, Chris. Yeah, he's interested in the rim joist situation, and that's good. Chris is just the kind of guy that I think is going to come up with a very nice custom built home. He's getting back to a comment he asked me before about something to put on the inside of the rim joist to prevent air leaks. Air leaks, so outside air leaking in, that's something different than keeping water vapor from penetrating and condensing. Those are two different functions. You mentioned, Chris, that you didn't want to use any spray foam. There really is no better way to seal things than with spray foam. It just works so well. It's not cheap. It requires particular application, but in your case, if you were to use the method that I recommended, if you wanted to stay away from the foam and use that cutout piece that I was telling you about, then that's going to work quite well too. That's going to seal very well. Your siding or whatever you put on the outside of the building will stop any liquid water from coming in, driving rain and stuff like that. But the foam, the rigid foam with the injected foam around the outside, that's going to seal things properly. And if you don't want to use spray foam, then that's the way to go. So ask some more questions if you like, Chris. I'm happy to answer them here. Okay. I think that seems to be, unless I've missed something here, I don't think there are a whole lot more questions come in just immediately like this. But I did get some ahead of time. And let's see. One of the most common questions I get, actually, I think it's probably the most common question I get, has to do with decks. Decks are kind of funny. They're kind of like a trap in a way. I mean, a homeowner wants a deck. They see lots of nice decks around. They go online, they look in magazines, and they have a deck built, but they don't realize something. And the thing they don't realize is how much ongoing effort it takes to keep a deck finished properly. This is a very common scenario. Someone puts on a finish in a year, it looks terrible. They struggle to renew it in some way, and in another year it still looks terrible, and they wonder, what's going on? What am I doing wrong? Well, there's a couple of things you're probably doing wrong. One of them, it just won't last very well no matter what you do. I mean, products that leave the wood looking new and bright, for instance. A lot of people they want to preserve their deck so that it looks new and bright all the time. what you don't realize is it takes annual reapplication of a product, and even stripping and sanding sometimes, to maintain that bright look. Nature does not like new wood, and so that's a problem. You might not be using the right stuff. You might be using a product that's just substandard. There's lots of deck products out there that won't last very long at all, clear or not. Another common issue is the lack of proper preparation. And by that, I mean pressure washing the deck first, and then followed by a sanding. Wood deck finishes really need to go down on a surface that's been sanded in some way in order to be absorbent, because new wood is not very absorbent. Finish won't penetrate into the wood cells, so it peels off fast. And old wood is also a problem. It looks very absorbent, and it is, but the surface fibers of old wood are loose, and they can let go from the board underneath, allowing the finish to go with it. So proper prep is another thing. And there are some people, and more all the time actually, who just don't want to have anything to do with their deck finishing. It's just too much work. That's not why they have a deck. They want to enjoy it, not work on it. So for people like that, I recommend a couple of things. How do you feel about a deck that looks gray and looks kind of like barn board after a while? No maintenance required. That's an option, and you can make that option look better if you use one of the one-time deck treatments. The kind I like best is called Eco Wood Treatment, and it's a powder that you mix with water. It's completely non-toxic, and you just kind of slosh this watery tea-like mixture over your new deck, and it will make the wood turn universally weathered looking in a matter of days, sometimes weeks, sometimes it takes months to happen, but the effect is a nice even brown color, and it looks great. The other option is not to build a deck with wood on the surface. So that means some sort of composite material used for the top. You still will always have to use wood. Well, at least now you have to use wood for the structure. There isn't an economical, widely available replacement for structural wood, but products like Trex, for instance, that happens to be my favorite composite. I've used it for years. I think it's great. It sits on top, and you don't have to finish at all. You just have to keep it clean. And more and more people, they seem to value leisure more than they used to. They're less interested in getting down on their hands and knees on a weekend and refinishing their deck. So that's an option that you might consider as well. Let's see if anything new's come in here. Okay. So Lloyd is asking, what are interior finishing options? Planning to use pine boards other than drywall. There seem to be few options. So I take it, Lloyd, you're wondering about interior options for interior walls. Well, drywall is the most popular. I'm not a particularly big fan of drywall, although I have a fair amount of drywall in my life. But none of the drywall in my home or my workshop or another home that we built on our rural property here is the standard 1/2 inch drywall. I really like 5/8 thick drywall. So that's only 1/8 of an inch more. It doesn't sound like much, but it actually amounts to quite a bit of extra solidity. And then beyond that, I really like 5/8 fire code drywall, which is required in commercial installations, and it has reinforcing fibers right in the gypsum. So you put those two things together, extra thickness and then the reinforcing fibers, and you will get a noticeably stronger surface that is a lot easier to like than standard 1/2 inch drywall. But maybe you don't want drywall at all. So in cases like that, you can do some amazing stuff with veneered plywood. So this would be cabinet grade plywood that would go up on the wall. It can go directly on the wall frame, and then applied to it is some wainscoting sort of a patterned installation with stiles and rails, and that can be painted or it can be stained as well. And that can give a very formal appearance. It can be quite beautiful that way, and there's a lot of scope for creativity as well too. I've seen different situations. I guess in a home, of course, those are really the two options: some kind of wood, drywall, heavier than usual. There is plaster out there too still, if you want a painted and fairly smooth surface. Nowadays, the way plaster goes down is that there's boards, sort of like drywall, that go down, and then a skim coat of plaster on top. I mean, that works quite well. Gives you even more solidity than with the 5/8 inch board. If you've got a workshop, though, especially a workshop where things are going to get dirty, one of the really neat things that I've seen used is metal roofing used on the walls. So this comes factory finished. It's not a formal wall surface, but it looks terrific in sort of a workshop or storage shed situation. And you mount this to the wall with the same screws that you'd fasten the material to your roof. It works very well. It's fire resistant and tough and waterproof, and does quite a good job. There is something I've seen done a couple of times on ceilings that makes it look quite interesting. Nowadays, metal roofing comes in all kinds of configurations, factory finished and usually fairly low profile, but you can still get that corrugated, unpainted metal roofing, and it's kind of silvery in color. And I've seen that used on a ceiling, so right up against the joists of the ceiling, and it looks fabulous in a kind of retro and industrial kind of way. So I hope that helps. Let me know. One of the things to keep in mind, even if you're averse to drywall, you can really minimize the amount of drywall that's visible with wainscoting. Wainscoting is a beautiful treatment. I wish I saw it more often, but you can get a fairly short 3 feet. You can also get taller installations. And to my eye, when you have drywall, good, nice, solid 5/8 inch fire code drywall painted white with some dark wood wainscoting and trim and things, it's just a fabulous combination that really looks beautiful in a timeless sort of way. So I've been talking for about an hour now, and we're getting close to the end. Let's see here. Oh, we got some more questions coming in. Okay, insulating an attic space. This person has used soffit vent baffles on the interior roof deck, thinking about using cellulose insulation in the area near the soffit on top side of the baffle. This is from Dan. Well, in order for a regular attic to be ventilated properly, it needs to be open to the air, to the exterior air. So the insulation that's in your attic is actually kind of on the floor of your attic, and the space above needs to be ventilated to the outside. That's to allow moisture vapor to waft off, especially in wintertime. And it also keeps the roof temperature cooler in the summer, so your shingles will last longer. So in an effort to keep an attic space ventilated, there could be openings at the gable ends, so the triangular ends of your roof, if you've got a roof like that. There can be vents on the top. They look kind of like square mushrooms in lots of cases, or whirligigs on top of the roof. I'm not a big fan of those, but then there's also ridge vents. So these are fairly low profile. They just raise the ridge of the roof a little bit and leave an opening there that's sheltered, but still open for air. But in order for all these to work, your roof also needs to be open to ventilation along the eaves. And that's when Dan's talking about baffles, that's what he's talking about. These things in your attic that keep the insulation away from that little gap along the eaves that's necessary in order to have continuous ventilation. So in my experience, you can have the insulation go right up to the bats, but certainly not over the top of them, because they have to be open. The purpose of the bat, it's kind of like a trough-shaped piece of foam that fits between the rafters and maintains this space so that air can be exchanged there. And that's pretty important because you don't want any excess moisture building in your attic, and you don't want your attic to get too hot. So Dan says he's thinking of using cellulose insulation in the area down near the soffit on the top side of the baffle. Well, if by top side you mean the side that's connected down to that opening at the eaves, maybe where there's some perforated aluminum or something, then you don't want to put any insulation there. It's got to stay underneath, so not on the top side, but on the bottom side. And it would be wise for you to go in and check all of those and make sure that they're still open. So I don't know if I've got your question right, but contact me, Steve at stevemaxwell.ca, and if I can help you in a more detailed way, then I'm happy to do that. So, okay, so Josh is wondering what the best way to heat his two-car garage and wood shop. He's planning on insulating and drywalling the walls, ceiling, and door. Well, the best way to heat, well, for me, best usually involves most economical too. I mean, there are other options, but economy is very important. And I wonder if you have enough room or you have an inclination to put a wood stove in there. Now, a wood stove is not going to heat the place automatically. If you've made some furniture and you finished it, and that finish has to remain at room temperature for at least a couple of days, if not longer, then a wood stove is not really going to help you completely. But a wood stove is a great way of lowering your heating cost, especially if you've got a wood shop in your garage, because you're going to have a lot of scraps. And you can burn those, you can burn old pallets. So when you're there, and you're there to available to manage this wood stove, well, I think that's a great idea. Wood stoves they turn, well, almost what amounts to garbage into valuable heat. Just garbage wood can yield wonderful heat. Now you will probably need some sort of a backup, because as I said, you don't want to have to be there all the time. You don't want to get up in the middle of the night to stoke your wood stove because your urethane finish is still curing. So one of the best ways of heating a shop and garage that I've seen, if you've got the ceiling height, is the radiant gas-fired ceiling tubes. So these run on natural gas or propane, and it's a pipe, black iron pipe about this big around, and it's mounted to the ceiling, and there's a reflecting shroud, like a trough, that goes along its full length, and there's a gas flame in there, and it delivers a lot of heat in a radiant way. So I don't know of any method that can heat a space faster than something like this, because it's not just relying on conduction to heat the air around it. It's actually shining down the heat. So within moments of turning it on, you walk into the shop and you're going to feel that warmth coming down on you. And it's all thermostatically controlled, pretty economical too. And it's because there's no fan sucking in air, it's not susceptible to dust the same way a furnace would be. So if you've got the ceiling height, and especially if you have access to natural gas, which is substantially cheaper than propane, even though they're chemically similar, natural gas is delivered more or less automatically through pipes, as opposed to propane, which has to be trucked in. And so it gets to be a lot more expensive. But those radiant ceiling tubes, I've seen them work fabulously well, and I think you'd be pleased with that. So hope that helps. Let's see. Well, I've got, I'm a little over an hour now. I'll see if there's another question or two I can fit in. Okay, this is a good one from Michael. What's the best foundation for a shed cabin, small, under 500 square feet? Pier, cement pad, gravel. Michael's in Maine, so his winter conditions are pretty similar to mine. I guess it depends on the dimension. I mean, you said 500 square feet. Well, let's just assume that's a square. So what are we looking at here? Maybe 20 by 25 or so. That adds up to 500 square feet. Once you get to a building of that size, I think you need more than just a basic foundation. That's what I would do anyway. If it's a garden shed, 8 by 10, 10 by 12 or something like that, then you can certainly put that building right on top of something firm that sits on the soil. My favorite option for that is what they call foundation slabs. This is like, imagine a patio stone or a patio slab, but it's quite thick and it's very strong, it's reinforced. For a small building like that, it doesn't really matter if the building shifts a little bit one way or the other with the frost. It's small enough that it's not gonna twist and get damaged that way. And if your soil is fairly light, well drained, so gravelly, sandy, things like that, if it's not going to hold the moisture, then that soil is not going to heave in the wintertime when it gets down below freezing, because there's no water in the soil to expand and cause problems. So if it was a smaller building, I would recommend the foundation slab option. But 500 square feet, you're getting up there. I would go with some sort of a pier. So this might be a round sonotube kind of arrangement. You can save yourself some trouble if you go with a fairly big diameter, like say 12 inches or so, pier, then that will act as its own footing for a building of this size. So you don't need to dig down and build a bigger footing out of concrete and then put your pier on. There is a product called a Bigfoot. It's a concrete form, and it's conical in shape. It's plastic. So you dig down below your frost line and you set up this conical Bigfoot form, and the top is sized to accept different sizes of the cardboard sonotube forms. And so you get all these things installed and backfilled, at least a little bit, and then you can fill them full of concrete. So the concrete goes down the tube, it fills in this conical bottom part, which really gives the whole foundation a wider footprint to sit on. And if you've cut your sonotubes all to the same level height, so for something up at 500 square feet, that's the trouble I would go to. A cement pad is an option too. I guess it depends on how you want to manage this building. Is it just for storage? Will it actually be a cabin that you might want to put running water in, or maybe just have some drains in the future? So see, with a concrete pad, you have to make all these decisions ahead of time, because the piping infrastructure needs to be there. Whereas if you have a pier situation and a wood frame floor up above, if you leave 16, 18, 24 inches underneath between the bottom of the floor joists and the ground, you can get in there and do all kinds of modifications and additions and things like that. I've made buildings of that in that way, and I certainly don't regret it. It's worked very well. There are very slick ways to insulate the floor too, if you ever wanted to do that. That makes me, I have another course actually. It's on building tiny houses, and that's the strategy I'm telling you about now with piers and a floor frame. That is what I recommend in my course. It's got plans and illustrations and 45 videos and all that stuff, and all the details are explained in that. So let's see. I guess that's about it. I've been talking at this computer thing of mine by myself in my workshop for more than an hour now, and I guess that's it. But I hope I've been of some service to you. And as I said, if you're interested in any of my courses, I have a course on tiny houses, building an off-grid energy system, managing a rural water system, reviving a failing septic system yourself without professional help. That's a very popular course, and it can save you 5 figures at least, and a lot of other hassle. Backyard chickens, small solar projects. I have courses on that as well if you're interested in just experimenting with solar and a bunch of other things. So it's really been my privilege to speak with you. You know, I know you guys are on the other side of this screen here, and you know, I didn't really enjoy connecting with you like this. My email, steve@stevemaxwell.ca, and my courses, diyuniversity.com. And maybe I hope I get to hear from you again. Anyway, bye for now. Have a good evening.